Good morning, dear student. Good afternoon, dear students.
Good afternoon, sir.
Okay, so we will see the fourth chapter, different oscillators. So we have completed Colpitts as well as Hartley. So now other type of oscillator we can see here is a crystal oscillator. So it is the best oscillator compared to the all other oscillators because of its fixed frequency oscillator. It will generate a constant frequency always. So without any limitations, it will get a constant output oscillations. Okay, so that is the reason mostly preferable oscillators in the any microprocessor, microcontroller, or digital systems. They are using this crystal oscillator as a major oscillator. Okay, so if you see the circuit, it is a natural quartz crystal. So it is naturally available in the earth crust, and it is in the it is like crystal. It is a structure, crystal structure. It is mainly the natural crystal is a quartz, and the equivalent circuit, if you see this is a quartz crystal. They have some layers in the upper side and lower side. This you can call as a plates. They will act like a metal plates, and that means inductor effect as well as capacitor effect as well as a resistor effect will be present. Then the equivalent circuit can be also represented by this circuit. Okay, so that means in a crystal, whatever you have there, that can be as these three effects. What are they? Inductor effect, capacitor effect, and resistive effect. And parallelly you can also have some capacitance effect. So this is the equivalent circuit of any crystal. So if you see, if you connect the crystal in the oscillator and for the transistor amplifier, it will act like this circuit. Okay, it will act like it is the equivalent circuit of this quartz crystal. Okay, so that equivalent crystal can be, if you have seen this circuit. Okay, circuit diagram of crystal oscillator. So this is a transistor crystal oscillator. So this is a transistor crystal oscillator because you are using an amplifier based on the transistor, and the feedback circuit you are using a crystal. Okay, so this crystal is used in the transistor with the feedback network. So here, in the place of the Colpitts oscillator, if you observe the Colpitts oscillator circuit diagram, you are replacing the inductor with the crystal, quartz crystal. So the equivalent circuit is same. So the circuit is same. The Colpitts oscillator and the crystal oscillator is same. So, but what is the difference is that in the place of the inductor, you are just placing the crystal. Okay. So the crystal will act like this equivalent circuit. So this equivalent circuit. Okay, so how it will be generated means the same thing. Whatever you are seeing in the Colpitts oscillator, in the Hartley oscillator, whatever the type of feedback you are given and what is the conditions obtained for a loop gain, and this is the reason. What is the reason it is behind it, you can get a sustained oscillations. Is it clear? So whenever whatever the type of conditions it is applied for a transistor amplifier. So what are the conditions? The conditions is called Barkhausen criteria. So that the condition, if you are satisfied, it will be behaves like a oscillator. Any transistor amplifier acts like an oscillator if it is satisfies the condition for sustained oscillations or Barkhausen criteria. Okay, so it will satisfy the Barkhausen criteria. That means the transistor will generate a 180 degrees phase shift, and this feedback network generates 180 degrees phase shift. So total phase shift around the loop is 360 degrees, and also the loop gain should be equals to 1, that is AV into beta equals to 1. So that AV beta is equal to 1 means, say AV beta is equivalent to 1 means beta value should be, what is the beta value for Colpitts oscillator? It is C1 by C2, correct or not? So it is C1 by C2, then it will maintain a AV beta equals to 1. So it will get a sustained oscillations. And what is the major advantage is that due to this crystal. So because the crystal is fixed, and it will generate a fixed frequency oscillations. So and it is not vary with the temperature changes. It is not changes with the beta parameters. It is not changing with the VBE. Okay, so it is not changing with any beta value or any VBE or any temperature changes will not affect the crystal. So that will not affect means it will not change the frequency. So that will not change the frequency means you are getting a sustained or constant output oscillations. So this is the fixed frequency oscillator. Crystal oscillator is a fixed frequency oscillator. So if you seen the circuit diagram and working principle is both are same. So even for outlay, even for Colpitts, the crystal oscillator is same. So what is the major difference is only this crystal. So if a crystal is different and the crystal is producing your fixed frequency output, and that is the reason it will mostly used in all digital circuits or microprocessor and microcontrollers. Okay, so this is the crystal oscillator and its working principle. Is it clear? So what is the advantage of crystal oscillator over the other types? Other types means LC oscillators. What are the LC oscillators? Colpitts as well as the hotline. So what is the major advantage or merits of the crystal oscillator is? So if you see in, before that, what is the merits and demerits of LC oscillator? So what is the major merits of LC oscillator is? What is the LC oscillator major advantage? It is a high frequency oscillators. Correct or not? And what is the demerits means it has the bulky size is high size is a very size because that it is due to inductor. Inductor is a heavy component, so that is the major drawback. So firstly, it is suffer from frequency instability and poor waveforms, and secondly, that can be used for we should not use for a very low frequency applications, and it is too much bulky and expensive. Okay, so this is the major disadvantages of the LC oscillators. And what is the merits and demerits of LC oscillators is, so it is used for the low frequency oscillation. This is the merit. And what is the disadvantage is it is not used for high frequency oscillations as well as what is the other thing, it is changes with the temperature. Okay, so this is the disadvantage of RC oscillators. So the disadvantage of RC oscillator is that they cannot generate very high frequencies. Okay, and what is the this is the disadvantage. And what is the advantage for a crystal oscillator is basic advantage is that it will generate a fixed frequency oscillator. It will not vary with the temperature changes. So this is the major advantage of crystal oscillators. Merit of LC oscillator is it will produce a high frequencies. What is the demerit is it will not produce the low frequencies, and it will not getting a fixed frequency, and it is instability with the instability of the frequencies, and it is also bulky. Bulky means size is high, and also due to the bulky size it will also cost high, expensive. It is also very expensive. So these are the merits and demerits of the LC oscillator. What is the merit of a RC oscillator is it will generate a very low frequencies merit. What is the demerit? Well, it will not generate a high frequency components, and it suffers with the temperature changes. Okay, so these are the two advantages and disadvantages. What is the major advantages? There is no disadvantage for crystal oscillator. It is majorly it is advantage. What is the advantage? It is fixed frequency oscillators. So that means you are generating a constant frequency and it will not suffer with the temperature changes. So this is the major advantage of crystal oscillators. And what is the reasons for instability in oscillators? And how to avoid the instability in oscillations? Okay, so we are talking about the what is the sustained oscillation means you are getting a constant amplitude and constant frequency in regular pattern. You are getting a constant frequency and constant amplitude, but most of the oscillators you are getting the frequencies which are fluctuating. So that why it is getting a fluctuation means there is a reasons. There are some major reasons we have a to fluctuate these oscillations. So what are the reasons? How to avoid that fluctuations? So that can be talking about here in this topic. Okay. So what is the major reasons for frequency instability in oscillator? Means that is frequency fluctuations in oscillator. Is first one is the changes in transistor parameters. So what is the changes in transistor parameters means? So if your beta value changes, the transistor value changes. If the VBE changes, the transistor amplification changes. So IC changes, that is temperature changes. So that will be change the output value also. So that is the major effect. Second effect is supply changes, variations in the supply voltage. If the supply voltage changes, output voltage also changes, because the input for a oscillator is from supply. If the supply changes, your output voltage also changes. So this is the second reason. Third reason is the temperature variation. Correct or not? The temperature changes, IC value changes. IC value changes, output current will change. Output current changes means output voltage also changes. So it is a major drawback. Temperature effect is on the semiconductor device, has the high effect. So it is also causing the instability in the fluctuation or fluctuations in the oscillations of any oscillator. So and other thing is it is the variation in the output load. So output value of the load value if it changes, so the output voltage also changes. So load value if you are changing, output voltage changes, so oscillations also change. And another effect is it is in a internal capacitance effect. The internal capacitance effect you can call as a stray capacitances. So we already discussed any transistor or MOSFET or any semiconductor device which are having some internal capacitance or stray capacitances. That say stray capacitances will have the effect in high frequencies. So in a high frequency values, that will be majorly affects the oscillations. Okay, and mechanical vibrations also disturb the frequencies or oscillations, and overheating of the components or the devices, and the imperfect tapping of the coils. Okay, so if you see the center tap transformer, so if the coils are not properly tapped, that means you're not properly you're tapping the coils, that also generates a that also leads to instability in the oscillators. Okay, so this is the major causes or major causes for your instability of the oscillator. Then if you have a if you have a this type of variations, then how to avoid? What are the remedies? What are the remedies you have to take in to avoid these fluctuations? Okay, so that will be you have to take some care to avoid of these fluctuations. So how to take the care means, first one is supply voltage variation can be overcome by using regulator power supplies. You have to use a RPS. So in the laboratory, if you see RPS or we are there in the laboratories, most of the laboratories we have a RPS, regulator power supply. That means it will be the output power will be regulated. It is you are getting a constant output source. So constant output source you will get means constant output voltage you are getting at the output of the circuit. So this is the major first remedy. Okay. Second remedy is the frequency stability can be increased by using temperature compensation techniques. So compensation techniques you have to use. So there are the several compensation techniques are there, neutralization technique. So different techniques are there. So you have to use if the temperature is increased, you have that compensation circuit or technique you have to use, that will be decrease the temperature effect. If the temperature is decreased means you have to increase the temperature. So overall effect will be constant. So that will be used to get the frequency stability or without getting any fluctuations. Okay, and the third one is the loading effects can be minimized by using buffer stages. Okay, so for example, if you see in the multi-stage amplifiers, so by connecting a two stages in between we have a buffer. So that buffer will reduce the loading effect. Yeah, that will be reduce the loading effects. Okay, and the other remedy is that the effect of changes in inter-element capacitor can be neutralized by adding a swamping capacitor across the offending elements. So you have to use a swamping capacitor. So that will be neutralize the effect of internal capacitances or stray capacitances. So another remedy is the frequency stability oscillation can be increased by using tank circuits of high Q. Q means quality factor. Okay. So you are using any oscillator circuit. If you see that will be used by the tank circuit or tuned circuit. The tuned circuit should be have the high quality factor. So if the high quality factor if you are using, the frequency of stability will be achieved. Okay, the frequency of stability achieved or fluctuation will be eliminated, and the coils must be tapped properly. We already discussed this. And the oscillator circuit must be oscillated from the source of mechanical vibrations. So you have to avoid the mechanical vibrations. You have to connect a circuit in awareness of this mechanical vibrations. So and temperature control chambers are used to minimize the temperature effects. Okay, so separate chambers are used not to reduce the temperature effect, or that is also called the temperature control chambers. Okay, that will be used to minimize the temperature effects. They are the eight eight problems you can call as, that is the reason for sequence of instability, are the problems, eight problems and eight remedies. So these eight problems and corresponding eight remedies you have to follow, not to reduce or you have to avoid the anyway instability in oscillators, or you can also say that in order to avoid the fluctuations in oscillators. Okay, so this is the remedies. And what is the last topic in the fourth chapter is comparison of LC and RC oscillators. So how you can be compared means, so depending on the frequency, depending on the frequency stability, depending upon the waveform shape, output voltage, tank circuit, cost and applications. What is the LC oscillator? What is the output frequency? High or low? LC oscillator has high frequency, correct or not? RC oscillator has low frequencies. Frequency stability, which one has the pure stability and which one has the RC oscillators? RC oscillator frequency stability is high compared to LC, because LC oscillators has a bulky in size. The size is more, and they will have the have the frequency instability. So poor in frequency stability is present in the LC oscillators. And waveform shape. Waveform shape means dependent on the frequency stability. If the frequency stability is less, waveform shape also less. So poor, it is poor in the LC oscillator, good in the RC oscillator. That means you are getting a good waveform, the correct waveform in the RC oscillator compared to the LC oscillator. Output voltage will be more in the LC oscillator than less in the RC oscillators. And tank circuit is made up of L and C, inductor and capacitor. So RC oscillator, it is made up of the R and C. So is it clear? Which one is high? The cost is high. In LC oscillator, cost is high because it is bulky in size. That is the reason it is expensive. And RC oscillators are low expensive. And applications are radio receivers. Okay, receivers we have using LC oscillator or tuned circuits or tank circuits. RC oscillators are used in AF, audio frequency oscillators, or AFO. AFO. We have also seen the frequency generators. Okay, frequency generators, AFO. They are called also frequency generators or frequency oscillators or AFO. So both audio oscillators simply you can also call. There you can use RC oscillators. In the laboratories, if you also seen AFO, okay, audio frequency oscillator. So that is made up of with the RC oscillators. Okay, so these are the differences between LC and RC oscillators. Is it clear, all of you? Are you able to understood, Bhavishya?
Sir. Yes, sir.
Is it clear,
Yes,
all of
sir.
you? The fourth chapter, very simple chapter because they
Sir.
all are oscillators. Okay, the circuit diagram and their working principle as well as advantage and disadvantage and applications. Only these things are present in the fourth chapter. Okay. All of you
Yes,
easily,
sir. Yes,
all
sir.
of you easily able to remember and easy to reproduce. Okay, so there is no problem. You can easily understand these concepts. Okay, so we will go for a fifth chapter, special semiconductor devices. So what is the special semiconductor devices? Means they will have a different semiconductor devices are there. So we have seen up to now is a normal components, semiconductor devices which are transistor, MOSFET, as well as some amplifiers. These are the normal components. So if you see the special semiconductor device, they will behave differently compared to your normal procedure of your semiconductor devices. Like if ferrite diode, UJT, photodiode, phototransistor, photovoltaic cell, LCD, and these are the some other character these are the some majorly used semiconductor devices, special semiconductor devices, because they are behaving special. That means their characteristics are different from your normal characteristics of any diode, transistor, or MOSFET, everything. Okay, so if you see in here, the first one is a varactor diode. So varactor diode is also called a vari cap or varactor diode, vari cap, variable capacitor or reactor diode. So this is looking like a PN junction diode, but not the PN junction diode, because the PN junction diode is forward biased and as well as reverse biased. But the reactor diode you should used as a the diode you should use as a reactor diode, that should be used in the reverse bias mode. That means you have to connect a P region to negative supply, okay, negative battery, and the N region should be connected to the positive of the battery. That means you have to connect it in reverse bias. So varactor diode always connected in reverse bias mode. In order to function a normal PN junction diode as a varactor diode or variable capacitor or vari cap, both are same, all are same. So if you are connected like this, you should connect it in reverse bias, because the why, because that it will act like a capacitor. So this region it will act like a capacitor. So the this is a dielectric actually. So and it is acts like a plate one, this is acts like a plate two. That means it is a simple capacitor. So and that capacitor's value you can easily vary by varying the supply voltage or battery voltage and junction width. Okay, so the width of the layers, the width of this junction can be varied, so that the capacitance value also changes. So how? Because it is the what is the formula for a parallel plate capacitance value? That value is equal to C is equal to epsilon A by D or W. So what is the W? Is that W is the width of the depletion layer, or D is the width of the distance between the two plates. Okay, what is the A? Capital A is surface area. So you can change the width of the junction or surface area of the junction. So you can change the capacitance value. So how to change this value of width of the junction? That will be changed with the varying the voltage, reverse bias voltage. So how that will be related with it is CT is K divided by under root VR. So what is the VR? VR is the reverse voltage, K is the constant. So it is inversely proportional. That means the reverse bias voltage is increases, capacitance value decreases. So if the reverse bias will increases, CT will decrease. If the reverse bias will decrease, CT will increase. Okay. So like this, that means the junction width will be changes. It is acts like a parallel plate capacitor. The variable capacitor or vari cap or varactor diode is a capacitor effect. You are it is not a normal diode. It is now a parallel plate capacitor only, because by changing the reverse bias voltage, you are changing the capacitance value. Okay, so if you see this construction wise, this is the P region, this is N region. So and you are connecting in the reverse bias. What will happen? So it will repel the whatever the there. So it will, what will there? What is the this positive potential will attracts the electrons present in the N region. So what will happen? These electrons will pull up like this. They will pull up and it will attract towards the positive plate. And here what is this P region? So P region is connected to the negative battery. So negative battery, what will happen? P region is majority charge carriers are holes. That holes are pull up. That will be pull up towards the negative side of the battery. That means you are increasing the width of the junction. So if you are increasing the junction means you are increasing the dielectric. If you are increasing the dielectric or distance between the plates, what will happen? Capacitance value will decrease. Width will increase, capacitance will decrease. So and also it is also depends upon the VR, reverse bias voltage. If your reverse bias voltage increase, so capacitance value also decreases. Okay, so this both ways you can control the this capacitance effect of a varactor diode. So this is seen in the working principle of varactor diode. So the reverse bias, it is considered to be a reverse biased PN junction diode, and the depletion region formed between the P and N region do not have any mobile charge carriers. Correct or not? Depleted of charge carriers. That is the reason it is a depletion region. So there is no charge carriers, and they have that is there is no holes, there is no free electrons. So it is hence it is a dielectric. It is an insulator. Insulator means it is a dielectric. It will act like a dielectric. Now N region is essentially it is a high concentration of majority charge carriers of what? Electrons, and the P region is a majority charge carriers of holes. So when you connect in the reverse bias, what will happen? They the the battery will pull up the whatever the free charge carriers present in the N region as well as P region. So N region is full of electrons, so that will pulled towards the positive terminal, and this P region is full of holes, and they are positive charge carriers that will pull up to the negative terminal of the battery. So what will happen? Due to this, the depletion region will increase. So depletion region increase means capacitance value will decrease, because what is the parallel plate capacitance formula? What is that? It is epsilon A by W or D. What is the D? D or W? It is the distance between the plates. So it is a plate 1, it is a plate 2. So in between this dielectric acts like it will insulator that the depletion region will act like a dielectric. Okay, so it will a capacitor effect. So in this PN junction diode, which is a varactor diode, which is normally used as a capacitor, where they can be used receivers. So in the optical receivers or AM receivers or FM receivers, mainly in the FM receivers, these varactor diode can be used, because the frequency is varied with the capacitance, because F is equal to 1 by 2 pi under root LC. So L value can't change that much easily. So C value you can change. So that is the reason why varactor diode are used in the FM receivers. Okay. So this is the formula for parallel plate capacitance value, and this is formula for a reactor diode with respect to the reverse voltage. So what is that VR power N? So we are under root VR. So under root VR means N equal to 1 by 2. So for N equal 1 by 2, for which purpose? Abrupt junction. So abrupt junction, and there are two types of junctions are there. Abrupt junction or step junction. This is also called a step junction. Abrupt junction is also called a step junction and a linearly graded junction. So there are two types of junctions are present. So for a linearly graded junction, it is n value is equal to 1 by 3. So for a step junction, it is a n value equal to 1 by 2 or root 2. Okay. So both are same. So this is the varactor diode and principle of varactor diode. So what is the characteristics means? So this is the characteristics. So that means, so as your VR value increases, capacitance value will decrease. Correct? Or VR is inversely proportional to the C. C is inversely proportional to the root of VR. That means it is they are inversely proportional. So that means the capacitance value decrease as the VR is increased. The reverse bias voltage increases, capacitance value is decreases. This is the characteristics of the varactor diode. And what is the symbol means? So this is the symbol. So diode and two capacitors, two parallel plates. So diode plus capacitor. This is the varactor diode symbol, and this is the equivalent circuit. So capacitor, resistor, and resistor, series resistor and junction resistor, junction capacitance and junction resistance, and series resistance. So this is the overall the varactor diode can be represented through this circuit. So this is called the equivalent circuit, and this is the symbol of the varactor diode. Okay, is it clear, all of you?
Yes, sir.
So what is the varactor diode or varicap or variable capacitor? What is the variable capacitor? Tell me, anyone. What is the varactor diode or varicap or variable capacitor? It is also called VVC, voltage variable capacitor. Okay. So it is also called variable capacitor or varicap or varactor diode, or it is also called VVR, variable voltage regulator or variable capacitor, variable voltage capacitor. Okay, so this is the all are same. So what is the varactor diode? The simple definition: varactor diode is a special semiconductor device of PN junction diode which is used as a capacitor, variable capacitor. Okay, is it clear? This is a special semiconductor PN junction diode which is used for the variable capacitance. Okay, and majorly used in the FM receivers, and it is majorly operated in the reverse bias mode, and it is a parallel plate capacitance effect. Okay, so what is the characteristics? How it will relate the variable capacitance is related with the reverse voltage? How it will relates? What is the relation between reverse bias voltage and the
Reverse
variable
vo-
capacitance?
when reverse voltage increases, capacitance decreases, sir.
Very good. It is inversely proportional. So it is inversely proportional, and that inversely proportional is depends upon the type of the junction. So if the junction is a step junction or abrupt junction, it n value is equal to 1 by 2. If it is linearly graded junction, n value equal to 1 by 3. Okay. So like this you can also see. So this is the your today class. So we will see the next class, different other devices, UJT and photodiode, phototransistor like this. Okay, is it clear, all of you? So you have
Yes, sir.
exam on 22nd, correct or not?
Yes, sir.
So we will before that only you have to wind up the your subject. So that means you should attend, all of you, compulsory. Only 12 members are attending now also. So this is a very not good sign. Okay. So there is so many absentees are present, which is affects your percentage. So that is the reason all of you join, and regularly. ఓకే, అందరూ జాయిన్ కావాలి, అందరూ వినాలి. ఎందుకంటే మనకు పర్సంటేజ్ తగ్గిపోతుంది ఇప్పుడు, పాస్ పర్సంటేజ్. ఎందుకంటే టైం తక్కువ ఉంది మనకు, 1 మంతే ఉంది, ఎగ్జాక్ట్లీ 1 మంత్ ఉంది ఇంకా. అందరూ చదువుకోండి, రెగ్యులర్గా అటెండ్ కండి. ఇప్పుడు ఉన్నాయండి రివిజన్ చేసుకోండి, ఇప్పుడు వరకు ఉన్నాయండి. ఓకే, so we will
Okay, sir.
also see the fifth and sixth chapters. So in this 1 month time, you have to complete this chapter as well as you have to revise. Everything is there. That is the reason you have to revise now onwards. First chapter itself you have to revise. Hmm? But simultaneously with this subject, continuous with this subject, you have to also revise the previous chapters. This fifth and sixth chapter, along with this fifth and sixth chapter, you have to also come across with your first chapter, second chapter also. Okay, it will help you much better. Thank you. So all of you. So we will meet in the next class.